Question 5. Ben is a wedding planner. He needs to order flowers for the wedding that are taking place next month. The 3 types of flowers he needs to order are roses, hydrangeas, and peonies. Based on his experience, Ben forms the following constraints on the number of each type of flower he will need to order. At least 3/5 of all the flowers must be roses. For every 2 hydrangeas, there must be at most 3 peonies. The total number of flowers must be exactly 1,000. The cost of each rose is £1, the cost of each hydrangea is £5, and the cost of each peony is £4. Ben wants to minimise the cost of the flowers. Let X represent the number of roses, Y the number of hydrangeas, and Z the number of peonies that he will order. Part A says formulate this as a linear programming model in X and Y only, so we're not allowed to use Z, stating the objective function and listing the constraints as simplified inequalities with integer coefficients. So let's go and have a little look at this model. So part A, I'm going to go through and I'm going to think about my constraints first. So we want this to be subject to. So we know from here that looking at those bullet points in the question, at least 3/5 of all the flowers must be roses. So 3/5 of all of them must be roses. Roses is X. 3/5 of the total is going to be X. 3/5 of X plus Y plus Z. So X needs to be greater than that. We can tidy that equation up by multiplying through. So 5x is greater than or equal to 3x plus 3y plus 3z, which tidies up to give me 2x is greater than or equal to 3y plus 3z. Just going to leave that there. We know it's in X, Y, and Z at this point, but we will get back to that. So this one here is that first bullet point. The next one, for every 2 hydrangeas, there must be at most 3 peonies. People often get these ones the wrong way around, these inequalities. So 3y is greater than or equal to 2z. Because if these were to be the same, so if it said for every 2 hydrangeas, there must be 3 peonies, so just ignoring the sign and just trying to get the coefficients right. If there were 10 of our hydrangeas, 3 times 10 is giving me 30. 2 times 15 is going to give me 30 as well. And if we think about the ratio of 10 to 15, that's in the ratio of 2 to 3. Some people like to start with this by forming a fraction as y over z is equal to 2/3 and going from there. So that's all we can tidy up with this one now. So the next one, we know that there must be exactly 1,000. Now this one is slightly odd for a linear programming question because you very rarely are told exactly. You are told it has to be less than or greater than or an inequality. So this is going to be where we're able to unlock and remove the z, because we know that z is there for 1,000 minus x minus y. Using this and putting it back into these constraints up here, we can see we'll then be able to eliminate z. Whilst we're just in this stage, I'm just going to write down my objective function. So I want to minimize the cost, and the cost of each of them. A rose is £1, so 1 times the number of roses plus 5 times the number of hydrangeas, and then plus 4 times the number of peonies. So at this stage here, everything is in terms of x, y, and z. So I'm now going to say I'm going to remove z. So removing z, and we're going to use z is equal to 1,000 minus x minus y. So to be able to do this, we're going to get, looking at that first inequality, 2x is greater than or equal to 3y plus 3z, which is 1,000, minus x minus y. So 2x is greater than or equal to 3y plus 3,000 minus 3x minus 3y. So therefore, carrying on with this, the y's are going to cancel out. We're going to get 5x is greater than 3,000. So therefore, x is greater than 600. Looking at the next inequality, where we've got 3y is greater than or equal to 2z, but removing that z. So multiplying that out, 3y is greater than or equal to 2,000 minus 2x minus 2y. So 5y is greater than or equal to 2,000 minus 2x. We can take that over to make it 2x plus 5y is greater than or equal to 2,000. And then finally, we've got our objective function. C was equal to x plus 5y plus 4z, which is 1,000 minus x minus y. That's x plus 5y plus 4,000 minus 4x minus 4y, which tidies up to give me y minus 3x plus 4,000. So I'm now going to write my final statement. So minimize C, which is y minus 3x plus 4,000, subject to x is greater than or equal to 600, 2x plus 5y is greater than or equal to 2,000 and some, which we haven't stated yet, that x and y are greater than or equal to 0, so the non-negativity ones. So then, moving on to the next part, it says Ben decides to order the minimum number of roses that satisfy his constraints. B, part 1, calculate the number of each type of flower that he will order to minimize the cost of the flowers. And part 2, calculate the corresponding total cost of this order. So, for this, B part 1, we now know that x is equal to 600. So therefore, 2x plus 5y is equal to 2,000. So we then know that's 1,200 plus 5y is equal to 2,000. So 5y is equal to 800 and y is equal to 160. So the reason why you can keep your inequalities in here absolutely fine, but because I know I want the minimum one, and this has to be greater than or equal to that, the minimum one's going to be when it's equal to, so 160. And then we also know that x plus y plus z has to equal 1,000, so 600 plus 160 plus z is our 1,000. Sorry, I missed a zero off there. 1,000, so therefore 760 plus z is 1,000. So z is equal to 240. Part 2 of this is to work out the cost. So the cost is equal. Now you can choose to substitute into the original we found of x, y, and z if you really wanted to, but I'm just going to go for the y minus 3x plus 4,000 because it's going to give me the same result. Y is 160, x is 600. So tidying that up, we get £2,360.